Hello, honors pre-calculus students. Mr. Cazzato. Today's learning target is to talk about angular velocity and linear speed. We're going to start out with angular velocity. So here is the definition of angular velocity. I'm highlighting it in yellow. Angular velocity of an object in circular motion is defined as the amount of rotation per unit time an object travels around a circle. We tend to use the Greek letter omega for that, so it looks like a W. So W is equal to theta, and it always needs to be in radians, so that's the amount of rotation over some time frame. So angular velocity is defined to be radians over time. So if you look at problem number 1, if an object is traveling 5 revolutions every 4 seconds, we want to find the angular velocity. So right now, I have 5 revolutions over 4 seconds. So I think of this as a chemistry problem. I need to convert revolutions to radians. So I know that 1 revolution is equal to 2 pi radians. So I need to multiply by 1 creatively. Since I want the revolutions to reduce, I'm going to put 1 revolution in the denominator and 2 pi radians in the numerator. When you do that, you can see that the revolutions reduce. So this simplifies to 10 pi radians per 4 seconds, which is 5 pi over 2 radians per 2 seconds. So the definition of angular velocity is radians over time. In problem number 2, what is the angular velocity of the hour hand of a clock? Feel free to pause the screen and think about that question. So if you think about a clock, how long does it take to go around a full circle? So it's going to go around a full circle, 2 pi radians, in how many hours? Well, it takes 12 hours to go around for the hour hand. So this reduces to pi radians per 6 hours. So if you think about this, that means it's 30 degrees, because pi over 6 is 30 degrees. So the hour hand rotates 30 degrees every hour. Let's look at problem number 3. What is the angular velocity in radians per second of a 28-inch bicycle wheel if it is traveling 20 miles per hour? So right now we have this unit, 20 miles per hour. And the goal, I'm going to write the goal off to the right, is to get radians per second. So as I mentioned, I think of this more as a chemistry problem. So we need to convert hours to seconds, and then we need to convert miles to radians, because we need to match up the numerator and match up the denominator. So we need to remember that 5,280 feet is equal to 1 mile. Since I want the miles to reduce, I'm going to put miles in the denominator. So 1 mile is 5,280 feet. Now I need to convert somehow feet to radians. And we have a 28-inch wheel. And for clarity, this 28-inch is the diameter. So since the wheel is in inches, let's convert feet to inches. 1 foot, I'm going to put that in the denominator, is equivalent to 12 inches, so that number is 1. And then somehow I need to get inches to radians. Well, we know a full rotation, or 1 revolution, is 2 pi radians. We also know a full rotation is also called the circumference. So the circumference is equivalent to 2 pi radians. So the circumference, I'm going to write that down. The circumference is equal to 2 pi radians. So this is an important conversion factor. Just like earlier, 1 revolution is 2 pi radians. So the circumference of this wheel is 28 pi inches. And notice I put the inches in the denominator, and that's equivalent to 2 pi radians. So that red number is also 1. So at this point I have converted the miles to radians, because if I look at the units, miles reduce, feet reduce, inches reduce. So now I need to convert the hours to seconds. So I'm going to again creatively multiply by 1. We know that 1 hour is 60 minutes. We also know that 1 hour is, I need to backtrack a little bit. We also know that 1 minute is 60 seconds. So if I were to look at this, the hours reduce, the minutes reduce. So now we have seconds in the denominator, and in the numerator we have radians. Now I type this in exactly the way I see it. I put a parenthesis around the numerator, and then I hit divide, and I put a parenthesis around the denominator. And every year people have trouble typing this in, and we all get different answers. So I would suggest you type this in and see if you can come up with 25.14 radians per second. The second learning target today is to talk about linear speed. So linear speed, I highlighted it in green. I tend to think of linear speed, and in most textbooks use the letter V for linear speed in math. So linear speed I think of as distance over time. If you've had physics, velocity involves direction. So linear speed is just distance over time. You should know that distance is equal to rate times time. We're going to skip problem number 5, and we're going to take a look at problem number 6. So in problem number 6, a wheel has a radius of 18 inches, is rotating at 850 revolutions per minute, RPMs, revolutions per minute. Find the linear speed in feet per second. So I'm going to start off with the rate that I know, 850 revolutions per minute. I'll write that down. And the goal is to get feet per second. So I'm going to write that off to the right-hand side. So we need to multiply by 1 creatively. We need to convert revolutions to feet, that's in the numerator, and minutes to seconds. So let's take care of the minutes and seconds. We know that 1 minute is equivalent to 60 seconds. Notice I put the numerator as the minutes, so the minutes will reduce. And now I need to convert revolutions. Well, I do know that 1 revolution, I'm going to put that in the denominator, is equivalent to 2 pi radians. I also know that 2 pi radians, put that in the denominator, is equivalent to the circumference. And since the radius is 18 inches, the circumference is 36 pi inches. So at this point, I have reduced the minutes. The revolutions have been reduced. And a radian is simply a real number. So right now I got inches over seconds. So I just need to convert inches to feet, and we know that 12 inches is equivalent to 1 foot. We want the inches in the denominator, so 12 inches is 1 foot. As I mentioned, I like to put a parenthesis around the numerator, divide parenthesis around the denominator, and when you type this into your calculator, you will end up getting 133.5 feet per second. Now I will point out that some people do this a little differently. I'm going to move this up here. Some people start out with 850 revolutions per minute. They still multiply by 1 minute over 60 seconds. But some people like to combine these two steps here that I have the highlighter in green. Some people like to say, well, I know that 1 revolution is equivalent to the circumference. So 1 revolution is equivalent to the circumference. I'm going to write that down. 1 revolution is equivalent to the circumference. So some people combine what I underlined in green to 1 revolution is 36 pi inches. And if you prefer to do that, those two expressions are equivalent. And then you still need to multiply by 1 foot over 12 inches. If you do it this way, you will also get 133.5 feet per second. In the next video, we're going to take a look at a couple examples, and I hope you found this useful.